Venturi meter, that is a device used for measuring discharge when the fluid is flowing through a closed conduit. But at the same time, notch, that is used for measuring discharge when the fluid is exposed to atmosphere. Orifice meter and Venturi meters are used for measuring discharge when the fluid is flowing through a pipe, that is a closed conduit. Venturi meter, that consists of a convergent portion, a throat and a divergent portion. It is working on the basis of Bernoulli's theorem. That is Bernoulli's theorem, that is if when a steady, ideal, incompressible, rotational fluid flowing through any section, total energy remains constant. Then the basic principle of Venturi meter is, by reducing the cross-sectional area of the flow passage, a pressure difference can create. By measuring that pressure difference, we can measure the discharge. Here, when the fluid is flowing through this pipe having a diameter, here that diameter is 5 by 4. And normally the throat dia is half the diameter of the pipe, that is 5 by 4 by 2, that is 5 by 8. This is the pipeline, here is the convergent, and this is the throat. So pressure tapping is taking from the inlet and the throat. And pressure tapping is not taking from the divergent portion. Because when the fluid is flowing from the throat to divergent portion, initially the fluid is not in contact with that pipe surface, so that there is a tendency of flow separation. And after that, when the fluid is trying to come in contact with that region, there is a tendency of eddy formation. This eddies and the flow separation loses energy. So in order to avoid that energy loss, the length of the divergent portion is increasing. Then we can minimize that losses, but we cannot eliminate that losses. That is why pressure tapping is not taking from the divergent portion. Then here the length of the convergent portion is capital D minus small d into 2.7. Capital D is the dia of the pipe and small d is the dia of the throat. And then the length of the angle of this convergent portion is 21 plus or minus 1 degree. That is in the convergent portion. But in the divergent portion, it is from 5 to 15 degree. In most cases, it is 6 degree. And the length of the divergent portion is larger than that of the convergent portion. That is to minimize the eddy current loss, eddy formation, and flow separation due to that losses occurs. And here the pressure is tapping from throat and convergent, that is at the inlet of the pipe, not convergent, that is at the beginning of the convergent. Then it is connected to, in order to measure the pressure difference when a fluid is flowing through a pipe, pressure difference at a 2 point, we have to use a differential manometer. That inlet connected with the left limb and throat connected to right limb of the differential manometer. Here, first before starting the experiment, we have to open that valve fully and we have to note the level of the mercury in the left limb and the right limb. Then close the valve completely. Then after that, you have to check whether the level difference in the left limb and the right limb, is there any level difference. If there is any level difference, we can understand that some air is entrapped there. We have to first remove that air. That process is called the venting. In order to vent that, here there are 3 positions: isolated position, vent position, and the reed position. Then for venting, you have to put these 2 knobs in the vent position. After that, open this plug from there and open the valve slightly. Then the water is start flowing. And using this cotton waste, we have to close that end. Actually, we are applying a back pressure. Then while applying that back pressure, if there is any air, that will come out. And after that, you have to fold that end. Then please fold that end. Then after that, place the knob in the same position. Then place it in the read position. During the experimental time, it should be in the read position. Only at the time of bending, you have to put it in the bend position. Okay. Then after that, we can start the experiment from the beginning. Then open the valve slightly. That is, initially we noted the level difference in the left limb and the right limb. Suppose the level difference in the left limb is 8 and the right limb reading is, suppose it is 14, then 8 minus 14 minus 8. Then suppose 6 is the level difference. So within that 6 centimeter level difference, we have to take minimum, this is 14. That level difference, within that level difference, we have to take a minimum 6 set of reading. So first open the valve slightly and then measure note the left limb reading. Here a meter scale, then consider 0 as the reference. From that reference, you can note the left limb reading, and then the right limb reading, you have to transfer that to left limb, because in the right side that reference is not 0. So you have to take that level difference in the right limb reading to left side and take the level difference. Now it is, suppose if it is 2 centimeter is the level difference. Then after that, after keeping, then the water is flowing at one particular discharge. At that time, the level difference in that two section is 2 centimeter. And here is a collecting tank that is smaller in size. So that we have to note time for 10 centimeter rise of water. Then here a valve is here, close that valve completely. Then the water start rising through the piezometer tube. You have to note the time for 10 centimeter rise of water. So by using the formula L into B into H by T, we can calculate the actual discharge. And the theoretical discharge is using the formula A1 A2 into root 2 GH, A1 A2 into root 2 GH divided by root of A1 square minus A2 square. Here A1 is the area of the pipe and A2 is the area of the throat. That is, here the diameter of the pipe and the throat is given. And H is the level difference. Here this level difference H is in terms of mercury, but the fluid flowing is water. So that we have to convert that head in terms of fluid flowing. Here, in order to change that head is called the Venturi head in terms of water. That is equal to level difference H1 minus H2 into specific gravity of the manometric fluid minus specific gravity of fluid flowing divided by specific gravity of the fluid flowing. That means X into level difference X into SM minus SF divided by SF. SM is the specific gravity of the manometric fluid and SF is the specific gravity of the fluid flowing through the pipe. Then that head is in terms of water. That value you can directly use in the formula root 2 GH, A1 A2 into root 2 GH divided by root of A1 square minus A2 square. Then actual discharge by theoretical discharge is the CD value. Okay. Then here that the CD value is around the 0.9. But in the case of orifice meter, it is only 0.6266. Then by adjusting that valve from minimum opening to maximum opening, you have to take the minimum 6 set of reading. Each discharge position, that is in every valve position, that is valve closing and opening the valve, or from maximum to minimum or minimum to maximum. Place the valve in one particular position and note the head in the left limb and the right limb and the time for 10 centimeter rise of water, so that we can calculate actual discharge and theoretical discharge. After calculating CD value in all the discharge condition, then take the mean value. Okay.